Hi guys, and welcome back to our next video. Now here we are talking again for encryption, for cryptography, and this video I think is gonna be really interesting for you. What we're going to happen here is basically we're going to create a Python client, a Python server using TCP, and therefore we're gonna connect the machines. We're gonna see the communication and we're gonna see how they communicate, how they send message and receive messages, and therefore we're gonna see how we can encrypt the messages and decrypt them on the other side. So without further ado, let's get into action. We have my Windows 10 machine right here, my main one. I have my PowerShell running up here with IP 1.100. And here on my Kali Linux machine, which is gonna be my server one, here I'm running IP 102, I guess, yeah, 102. So these both machines have Python installed and have all the dependency. Of course, I'm gonna tell you how you can install all dependency if you don't have them. So without further ado, let's start and build up a simple client-server communication. So on my Kali machine, which is going to be my server one, you can see desktop or whatever you want, and now go for Kate, which is the text editor I can use, and let's say server.py. And when you do like that, the Python version is going to be by default Python 2, which is not a problem. You can go with Python 3, it's okay. So server.py. So when we type the syntax, when we run Python against the server, let's say when we type Python server.py, it's gonna run as Python 2. To run as Python 3, we can go Python 3 server.py. Okay, so we're ready. So Kate server.py. Now we're here, and I forgot to run it in background mode. Now we're talking. Nice. Okay, so import socket. This is the library, the module that we need in order to create communication. To create sockets, we need to import the library and the functions of socket. Okay, so now we need to basically specify and create a socket object, and that's done by using sock to specify the name. It can be socket, it can be S, it can be anything. This is just the name of our socket object. You know, Python is not like C. Python is object-oriented programming. It has object, it's working with object, so we are creating object. So S equal, or let's say sock equal socket dot socket, and this is the syntax you can find in the manual online, find it anywhere. Socket dot af inet. This is specifying that we are using the internet protocol, and therefore we need to specify socket sock stream, and this specify that we're using the TCP transport protocol. Okay, so therefore we need to bind that one. So sock has a function bind, so sock.bind double brackets, and now we need to specify the address. Okay, so it's always good to save everything as a variable. So we have host equals 192.168.1.102 and port equals 12345. Okay, now here we specify host, port, close that, and now s.listen 5. This is gonna force our server to listen for connection. Now we need infinite while loop, so we are listening to the infinity. Our server is running and it's constantly listening. That's why the loop is while. So we have while true, which is, as I said, the infinite loop. Now connection address equals sock accept. Nice. Therefore we need a buffer, so buffer equals connection receive 1024. This is just the received connection. The buffer variable, this is just a variable name. The buffer variable is just gonna be equal to connection receive and that amount of bytes. If we are awaiting more and more larger information, we can just go and scale it up and so on, but I think that 1024 is gonna do a perfect job for us. And now we can, for example, print buffer And now I think we are ready to go. I just need, you can send the connection back by specifying connection sent buffer, and we need to close the connection by typing connection close. Okay, so let's just see what have we done. So Python 3 and specify server, I guess. We have an error under sock stream. I think this is supposed to be all capital. Okay, svsum. Oh, sock, sorry. And now our server is up and running. So now it's listening for a connection. As we said before, it's using Python 3. We run that script under Python 3. To run it under Python 2, we can go with only Python. Server.py should work in the same way. Yeah, amazing. So now the server is actually listening for a connection. Nice. Now it's basically time to create a client, so we can go there and connect to our server and see what is going on. So let's just navigate my PowerShell here, and now clear that, cd to desktop, and now notepad client.py. Okay, nice. We have now a notepad open up on our desktop, and here I can write anything. Of course, you can use any text editor you want. It's the same as the Linux one. Okay, so now we are working for the client, and now basically we need to import socket again. So import socket. Therefore, we have to specify the host again. So host equal 192. It really does not matter if you use single or double quotes. It really does not matter. So 192.168.1.102. And now we need to specify the port, which is 12345 in our case. So now we need to specify a message that we want to actually send. So basically message equals let's say white, green, black, fox, for example. Okay, so I'm gonna use single quotes again. Okay, now nice. The next thing we have to do is basically to connect to the server and send the message. So we need another socket object. So I'm gonna just do it with the S. It's more easier. Now you know what's going on. So S equals socket, and in the brackets socket.afinet, which is exactly the same as the creating the server, and socket.sockstream, since you are specifying the interface, the IP protocol and the TCP, so it needs to be the same. If one of them is working on the UDP or different interface, it's not going to work. So here we need to specify connect, and now host port, and now s.sendo, and now we need to specify our message. But I think that is not going to work since it's expecting an object here, but let's just give it a try. So msg, now save that with Ctrl S, now go here and type python client.py, and yeah, a byte-like object is required, not string, so I think we have to do just b to specify it's now byte-like. And now if I run the script, I think the message is gonna send machine refusing the connection. Okay, is the server running here? Connection receive. I have an error. So okay, so my address is already bind in use. And when you're getting to such an error, the easiest way, of course, is to reboot your operational system. So reboot. This is, of course, the easiest solution. Is gonna refresh everything out there. So just wait a little bit. While the operational system is ready, make sure that your client is ready. So basically we have byte-like object, we have connection, and we have a send message. So whenever we basically run that script, to our server machine should appear a message with basically our string inside. By default, Windows is running Python 3, so yeah, root, my password. To try that, you can go there and type Python version and see Python 3.7. So clear that. Let's go back to my Linux machine. Let's just wait a little bit to vote, and now we're gonna retry the whole process. Okay guys, so here we are now back in our machine, and now what we're going to do is navigate to desktop, and we are going to basically run server.py. So python server.py, and before that make sure our firewall is disabled, so disable. Okay, exit, and now let's get back to PowerShell and rerun the script. So python clean.py, and see whenever we run the script, the white, green, black fox appear in my server server application. Here, no matter how much time I run that, it is going to appear on that terminal window. So that means the machines are connecting each other, they are successfully sending message, the server is successfully receiving message, and of course the server can resend the message, and the client can be coded to receive the message, but that's not the point here. We are just now going to step into encoding and encrypting, and you're gonna see how that is actually working. You see how much time I run the script, that much time the message appears on the terminal window. Nice. So now let's get back into encryption, and let's just rerun that, clear that, rerun. Okay, so now we know that our server and client communication is working. Yeah, right, we have server, client. Whenever we run that, the message appears, so they are communicating. So here, if we are basically implementing loops, implementing different functionality, we can make the machines communicate, even run commands, and so on. So it's time to get the things into next level, and for that case we need a key, and we need to encrypt our message with that key, and therefore we need to send that message. So the server is going to need to have the same key, so the server is going to get the key, basically decrypt the message, and then use the message. That's the whole idea. So here I'm gonna basically open up a new file, notepad, and this file is gonna be called, let's say, genkey.py. Okay, so I'm gonna create that. Do you want to create? Yes. So from that file I'm gonna import from cryptography .fernet, import fernet with capital, cryptography. Okay. So in order to basically have the dependencies up and running, you can go ahead and specify python-m pip install cryptography. So this is gonna collect all the dependency and it's gonna install it for you. You see, I am running the newest one, so I don't need that. So there's nothing to install. So basically Fernet is a framework that can help us encode and decode messages. There are a lot of functions there, and now you're gonna see just some of them. So here I need to specify a variable called key equals to, let's say, Fernet generate key. This is the one of the functions that Fernet has, and now we can just print out the key. So key. So whenever we save that, let's go to PowerShell and Python genkey. We see that we've generated some key, and it's like in bitwise. So how much time I run the script, the key is gonna be different. You see, each time I run the script, the key is completely different, but in order to make our work happen, we need exactly the same key. So now what we're gonna do is we're gonna save that key into file, we're gonna transfer the file, and therefore we're gonna basically use that file for encoding and decoding, so the key is the same. So just clear that. Now here, instead of print key, I can say file. So file, a file variable is equal to open, and now I need to specify the file name, so key.key in my case, and now we can specify the file mode, which is write binary. So here, now we need to file write and write the key to it, and then file.close. We can, for example, say print file was, or key was written successfully to the file, and I think that's okay. We can just go ahead and type different signs for making our program more realistic. So here, let's just try it out. The key was written successfully to the file. Okay, so now key again. I don't need that T here. I just need one space, and we are good to go. Okay, so we have a key in our file. So if I minimize everything, I see I have a file with a key, with key extension. If I open it, I have the key that was generated. Okay, so now since I have the key, I don't need that anymore. And now I need to encrypt my message with that key, send the encrypted message, and then decrypt the message using the same key. So first I'm gonna transfer the key to my virtual machine. I'm gonna, let's say, open up file manager. So here I'm gonna transfer the key, copy here, then from here move it to here. Move here. Nice. So now I have the key, which is there. So I can open a new terminal and cat key.key. Nice. Okay. So now I need to basically, as I said, encrypt the key. So I need to open my client. First the client needs to send, so I'm gonna start from there. You know, first the client sends, then the server receives. Server cannot receive nothing if client do not send. So now we have a pure message, pure string message. I need to remove the B before the message. And now what I have to do is basically open a file, read what's inside. So read the key and therefore encode my message. So here I have my message, and now I need to specify a file variable. So file equals to open. And now specify the file name, key.key, and now specify the mode, which is read. Nice. So here we have a key variable, which is equal to file.read, and since everything in that file is my key, it is going to be, the key variable is going to point to the whole key that's inside, because if the file has something else besides my key, it's gonna break my program. So you have to make sure that in the key file, only the key consists there. Okay, so we can go and let's say print or let's just print out the key. Yeah, just testing print out. So we can print out key. Nice. And now the next thing we have to do is we need to encode the message. So let's just try it out what happens to that moment. So we have Python clan.py. We are actually getting an error on the sendo because we've converted our message into a normal one. So don't worry about that, but we have the key right here. You know, it's in bitwise again. Nice. So here we don't need that print option now. What we need is basically an object of type fernet and another variable which is gonna store our encoded key message. So here we have basically encoded message to be equal to message.encode. So we're encoding that one. This is the message from here. We are calling the function encode, and to call the function encode, your message should be in pure string because it is in B. It's not gonna get encoded. You see? Okay. So we remove the B. It should be in the pure string, and now we encode that. Therefore, we need to specify an object of type fernet. So f for fernet equals fernet key, and now we need another variable which is encrypted message equals f.encrypt, which is function of fernet object encoded message. Now we can go there and print the message to see what's happening. So we can print encrypted message, and now let's see what's going on. Fernet key. Oh, we didn't import the fernet. Sorry. So from cryptography fernet import fernet. I think now it's going to work. Yep. So that's the encoded message right there. This is the message that we're going to send. You see it's a bitwise format, so there is not going to be any trouble to send that message whatsoever. So here, instead of send out message, we specify send out encrypted message. Nice. So now see if the server is up and running. Yes, it is. And let's now go and run our script. You see, we are sending encrypted messages, and it's encrypting differently. The message is the same, but it's differently encrypted anytime we run that script. You know, now the server do not know what's going on, what are those messages. Now we need to basically code the server to be able to decrypt the messages and see what the information has there up inside. So now we're pretty much done with the client side. Since we did what we needed, we've basically encoded our message. We read the key from a file. Therefore, we encode our message, encrypt our message, and send our encrypted message. So in the server side, we should do now completely the same. So here, just open up Kate. So Kate. So actually, I don't need that one. So I'm gonna Control-C that. I don't need that terminal. Now, Kate server.py. Okay. So here I need to import that again. So I need to import basically from cryptography.fernet import fernet. Nice. So now the next thing that we have to do is basically after we receive that message, we need first to basically open a file and read the key. But after we receive that message, to decrypt and reverse the whole procedure. So the first thing we have to do is to open up file variable again. So file equals open key.key with mode read. Nice. So therefore we need to specify variable key equals file.read. And now file.call, since we don't need it anymore. Nice. Because it's always good to close file streams, socket streams when they are not used. It's always good to close them. It can cause vulnerabilities. Okay, so we have the listening procedure right here, and we receive the message in a buffer variable. So we are printing the buffer. So now we need to basically decrypt the message from here on out. So here we need to specify again fernet object. So if equals fernet key. Therefore, decrypted message equals f.decrypt buffer, and now we need to basically print out the decrypted message. So we can just print decrypted message, and let's see what we have done. So we can just minimize that, close that, Python server.py, don't say it's used again. Nice. And now open up my PowerShell, and now clear that and run the script for client. We have the message and we have the decrypted message down below. So the first thing that we basically receive is the encrypted message, and now the program decrypts that message using the key. So here you see the encrypted message is always different, but knowing the key, the program is able to basically decrypt that message, and we get the exact same message down below. And now if you, for example, remove that print which is causing to show us the encrypted message, there will be no difference whatsoever from that perspective from the one that we firstly came up with without any kind of encryption. But now the messages are encrypting, and we're putting so much print statements to basically see what is going on with our program. Yeah, you see guys, just rerun that and we get the encrypted message, and using the key the program is able to basically decrypt that message and see the information inside. So this is synchronous encrypting when we have just using one key for encrypting and one key for decrypting. But if we are using asynchronous one, we need different keys. We need one private on my Windows machine, we need one private on my Kali machine, we need one public on my Windows machine, and one public on my private machine. So I'm gonna take the public of my Kali machine as a client. I'm gonna take the public of Kali machine and encrypt with that. So only that Kali machine can decrypt them, and the opposite. If the Kali machine is sending something to me, it's gonna send with our public key encrypted, so I can decrypt with my private key. So guys, this is today's video. I hope it was interesting for you. We did some encryption, we did some networking with Python, we did just simple TCP client-server communication using Python. You see, it's simple, it's easy. Python is amazing language. It's made easy. Everything there is made up easy. There are functions and libraries for almost anything right there. And we see even for encrypting there is a Fortinet library which basically allows to encrypt and decrypt so easy. So guys, I really appreciate you for watching. You can go around, play with different variables, play with different files. Try as a homework to basically implement that asynchronous one. Try to think yourself and implement that task. And I really hope you enjoyed. And there's one more trick that I want to show you about the firewall. Let's say if you enable firewall, so UFW enable, and we disable port 12345. So UFW disable 12345. What was the command? Deny, sorry. So not disable, deny. So deny. And now see what happens when we try to rerun the script. We get stuck. Our program is stuck, and now it should get an error because the firewall is blocking the connection. So it's trying to basically see the to renew the connection. It's trying multiple times. It has some exceptions that it throws. It tries timeout, and see we have connection rejected. Yeah, so that's the point of the firewall. And if we allow that port, so allow, now Control C to get the timeout time end. Now we run that again and everything's alright. Nice. Thank you guys for watching and see you in the next video.